As the world becomes increasingly interconnected and complex, digital twin, the dynamic replica of physical objects, is revolutionary in optimizing the design and operations. The connected digital twins of different economic sectors, AEC, aerospace, healthcare, disaster management, forms the national digital twin that is transforming the world, economy, and society. Geospatial infrastructure is critical to unlocking the plethora of opportunities offered by digital twin technology. Adoption of spatial digital twin provides for better visualization and broader insights. The digital twin market is expected to reach USD 73.5 billion by 2027, growing at a CAGR of 60.6%. Geospatial infrastructure and national digital twin ensures improved efficiency, better decision-making, and increased sustainability across all the economic sectors, thereby transforming lives of individuals by connecting the dots of past, present, and future through data.
Well, good morning. I can hear all the enthusiasm in the room after a late night last night. I kind of wish this session was tomorrow morning, then I could say May the 4th be with you, but today is the 3rd. I think we all understand the value of geospatial infrastructure and the impact it's having on nations around the world in terms of improved decision-making, better governance, and stimulating economy. Digital twins, obviously, as you've seen in the video, are becoming much more commonplace, particularly in construction and building operations, where we're increasing safety, reducing cost, rework, and error. And really what we want to talk about this morning is the combination of geospatial infrastructure and digital twins toward a national digital twin, that digital representation of the physical world, and how that may become a tool, a very potentially valuable tool for all of us going forward in the future to do better across the economic, social, and environmental landscape. What I'd like to do is to introduce our panelists and ask them to come up at this time. Paul Becker, President of the Federal Agency for Cartography and Geodesy, Germany. Paul, if you would come up. Christine Nayar. Christine Nayar, co-head of SGS Office, Federal Office of Topography, Swiss Topo, Switzerland. And Nigel Clifford, Deputy Chairman, UK Geospatial Commission. Welcome. And what I'd like our panelists to do is to take 10 or 12 minutes or so and give us your keynote comments about geospatial infrastructure and digital twins. And then we're all going to have an opportunity to ask questions of our panelists. So Paul, can we start with you this morning?
Good morning, everybody. Thank you very much for the kind introduction. And I'm very pleased to be giving a speech today on the digital twin for Germany, a topic I'm very passionate about myself. We all know how important it is to make quick and accurate decisions. Digital twins provide the foundation and the tools to tackle global challenges and are becoming increasingly important for our society. First, a few words about motivation. Disasters occur ever more frequently these days, especially natural disasters that are affecting society, environment, and economy. Forest fires have destroyed large areas around the globe. We have seen tremendous destruction. Never have there been more forest fires than the last year in 2022. And with digital twin, forest fire risk can be predicted and different response strategies can be simulated for effective and safe firefighting efforts. Also, digital twins can help governments and aid organizations predict how humanitarian crises will affect the infrastructure and resources of specific areas. Based on simulated scenarios, actions can be taken to provide quick and reliable solutions. The coordination of rescue forces can also be better managed with digital twins. Decision makers can be sensitized and trained for emergencies such as the flood disaster in Germany in 2021, where entire settlements were destroyed by heavy rainfall. City planners can use 3D models to better prepare settlements for disasters like the tragedy 2 years ago. Another example, last year, an unusually long period of heat led to drought and shortage of water. Over 70% of all health damage caused by natural disasters in Europe can be attributed to heat waves. Climate change will exacerbate this problem in the coming years. The question is, can this heat distribution be localized and predicted? How can the effects of heat waves be mitigated or even avoided? In Germany, we are not affected by all of those disaster events. Nevertheless, we have to be prepared for unforeseen heavy impact disasters. We are developing the digital twin for Germany to provide a solid data pool for the decision makers, to investigate how we can achieve equal living conditions and accessibility to important points of interest. How quickly can I get to the next hospital? Are there any poor connected neighborhoods? How would heavy rain events affect human settlements? The BKG responds to these requirements with the inception of a geospatial digital twin that will allow government authorities to model, simulate, and test the impacts of possible solutions and gain new insights into underlying effects. A keystone of a geospatial digital twin is a standard inventory of assets that would include 3D models and topography, points of interest such police stations, fire stations, and expert knowledge to bring it all together. Interoperability promotes data integration from different subject areas and elevates insight through better context. So to achieve this, the digital twin Germany will incorporate as much authoritative data as possible from existing, and this is important, from existing information systems and infrastructures of the federal authorities. Our focus is on the federal authorities. If we have the data, we can analyze it and start simulating various scenarios within the digital twin. BKG will capture the entirety of Germany within 1 to 2 years using the high-resolution airborne LiDAR. The result is a unique high-resolution 3D dataset with at least 40 points per square meter that is characterized by its homogeneity, and the entire country is captured in a temporally and methodically consistent way. So how is the data captured? Maybe you know it. Light emitted by the scanner in the direction of flight in pulses is reflected by the object and detected again by the sensor. From the position of the aircraft, direction and distance, a point is then generated in space. All points determined in this way form a three-dimensional point cloud. The important advantage of the digital twin Germany will be the uniform databases. In preparation for the digital twin, a demonstration project was carried out in the Hamburg metropolitan region. BKG tested the feasibility of the large-scale high-resolution data capture, and the results are impressive. With this technology, we are able to replicate vegetation, buildings, and infrastructure in a very realistic and precise 3D model. But the 3D replicas, which look very much like realistic images of the environment, are actually point clouds. I like to show you on this example how the point cloud forms the scanned object. Here you see an electronical tower, but it could also be vegetation, buildings, or any other visible object. Everything you just saw on our short trip over Hamburg consists of the point clouds. I would like to show you today only a small section of the application areas of a digital twin, because there are so many. For instance, Digital Twin Germany will support agriculture by incorporating weather data, data from sensors, and historical crop yields to make informed decisions about irrigation and fertilization. Risk associated with climate change can be mitigated due to a better understanding of potential impacts. Various data sources can be implemented in the digital twin, for instance, governmental data or data from the sensors. Decision makers can develop urban planning solutions for land use, transportation, or buildings. With real-time data, traffic patterns can be analyzed, risks related to disaster events can be simulated by identifying vulnerable areas. By simulating disaster scenarios such as heavy rainfall, prediction of natural disasters is possible. This allows for early warnings and evacuation measurements. Mainly having talked about the technical part of the digital twin, I like to highlight the need to prevent horrible disasters better in the future, such as one of the worst flooding in Germany's Ahr Valley in 2021. Due to heavy rainfall, many people died, were injured, or lost their homes. Whole settlements were destroyed. In the future, digital twins can help decision makers all over the world to simulate scenarios like this, to find sustainable solutions and measurements to safeguard society and environment. With our new product, the Heavy Rain Hazard Indicator Map, we already have a digital twin. By integrating data about buildings in a digital elevation model and to complete it with climate data, such as probability of heavy rainfall, it is possible to run such a digital twin. BKG has calculated 2 scenarios for a pilot region in Western Germany and will expand it to the whole country. The calculation was based on 2 scenarios for the prediction of water levels and flow velocities in the cities. The calculation clearly identified vulnerable areas if these events occur in this intensity. The digital twin heavy rain hazard indicator map will be part of our digital twin Germany, because that is what it is. A digital twin is an aggregation of several other digital twins, normally. We compared the actual extent of the flood disaster of 2021 in the region with the data simulated afterwards, the digital twin, in the digital twin, sorry. And the red line calculates the event, and the blue line is the simulation. And the results were very close to reality. You can see it. That proves the need and the benefits of digital twins, which will help us in the future to better prevent disasters and negative impacts on our environment and society. We just have started our journey, but already are excited about what we can achieve with the digital twin. It is not just capturing the data, rather than knowing how to use it. At BKG, we will operate an experiential 3D world ExaCube, which will help decision makers to experience disaster events and to develop solutions for the future. The ExaCube makes it possible to dive right into the simulation. You can experience how high the water would flood in the road you are standing on during heavy rainfall with realistic weather data. I like to highlight again the immense potential of digital twins to shape the futures in a more sustainable way. The digital twin for Germany will be, I'm convinced, a powerful tool to solve complex issues, improve quality of life and equal living conditions, but also to face the challenges of climate change. I'm confident that the power of digital twins will create a brighter, safer, and more connected future for all of us. Thank you very much.
Good morning. My name is Christine Nair. I work for the Swiss National Mapping Agency, and I co-head the Office for the Implementation of the Geospatial Strategy at Swiss Topo. I would like to speak today about the geoinformation infrastructures and the digital twins in the Swiss geoinformation strategy. So a couple of facts and figures at the beginning. The whole story starts in Switzerland in 2001 when the first strategy was passed. And it is the strategy is very closely connected to the law, which was passed in 2007, and the geospatial infrastructure in Switzerland, which was passed in 2008 and was ready running. It's called the geoadmin.ch. You can check if you would like. And it's really a pyramid. So the strategy is the basis, and the law builds up on the strategy. And then obviously the infrastructure is then the result out of the law. Many other components were added to this infrastructure in the following years. And so we did not start from scratch when in 2018 we got the mandate to elaborate on a new geoinformation strategy. And if I say we didn't start from scratch, we have a quite successful viewer, mapgeoadmin.ch, which for a small country as Switzerland is quite successful. It has 854 available data sets. It is 99.9% available. I won't read down all the numbers, but maybe 75,000 visits per day. So it is quite used and quite accepted viewer of the spatial data infrastructure. Also, we have a 3D data coverage of the digital terrain model in Switzerland, covering the whole Switzerland. So there was already quite an infrastructure there when we elaborated on the new strategy. And these are a couple of thoughts we had when we developed the new strategy. So as I mentioned, we would like to take the established with us. The components are good and successful, and we want to take them along. Nevertheless, it is always good to step back and think again, do the checks and balances. What have we actually achieved until now? Where do we want to go? And how do we want to improve? For example, in the area of open data, in 2021, the Swiss Topo data became open governmental data, so they became free for everyone to use. This was a very big step for us, and it makes it possible for many people more to use the data that we provide at Swiss Topo. So we want to use the good foundation, but we would like to improve and be critical also with what we have already. Of course, the user behavior has changed since 2001 drastically. Maybe a short poll here. How many people think here, maybe have own children, niece, nephews, or know people, let's say below 25, who actually use and are able to read paper maps versus the others who use Google Maps, other navigation system to locate a way they have to go from A to B. So how many people think that they still have people, no teens under 25 who actually still use paper maps and can read paper maps? Okay, let's check the other way around. How many people say that they rather use Google Maps and navigation systems? Okay, so I think it is a clear majority. So I personally don't believe that I'm very old yet, but I still learned how to read maps and I still like my paper maps. But see, I am already a different generation. So we need to account for these people. We need to account for social media, where people get their news from. We need to look at the behavior changes in society. Frameworks. there are many strategies in Switzerland. I am guessing this is probably not only Switzerland, that strategies seem to be growing. I don't want to say weeds, but there are many strategies. And it is probably easier to make your own strategy than to align your strategies with other strategies. In Switzerland, we have the e-government strategy we need to align with, and many other data strategies in other areas, mobility, energy, environment, that we need to align our geographical information strategies with. And it is important. We want to work together. Also on the international level, of course, GWF, for example, as a framework, we want to align with it. So this is an important aspect. And last but not least, of course, technology. So in our first strategy, we had not mentioned, for example, digital twins yet, but also artificial intelligence, big data, data science in general. These are building information models. These are important buzzwords, but also important technological developments we want to account for. So we need to use these opportunities. So what was the evolution of the Swiss geoinformation strategy and also the Swiss information infrastructure? At the beginning, and now I'm speaking a little bit symbolically, we had the different offices and stakeholders who might have had their little CDs with their data in their drawers. We wanted them in 2001 to get their CDs out and offer them to the public, to being able to access the geoinformation. Now, I think we have come one step further. Now, I think we want to not only have the geodata accessible, which I think we have successfully managed with our 854 data sets. We can always improve, of course, but we want to also interlink them. We want to make it possible that they are interconnectable. And then the next step we want to achieve, and this is what where the strategy goes, we want to build up a geo-knowledge infrastructure. So this is our vision for our strategy: from geodata to knowledge, linked and geolocated information for Switzerland. Now, where are we now? We're in the middle of implementation. We have every year a new implementation plan. It's called Action Plan. And we have learned a couple of things from the old strategy. For example, that it really is very, very crucial to involve the players and stakeholders from the different levels, federal levels. So, for example, I am a co-head of this strategy office. My partner is from the state level, so we call it canton in Switzerland. And we really do this on an eye-to-eye level. But we also involve communes, we involve private industry, and also different associations. So this is very important, but also the funding of the implementation. We have managed to receive some funding, and that is also something we learned from the 2001 strategy implementation. Now I would like to give my last two slides are just two thoughts I would like to present to you. These were things that we were thinking about when working on the strategy. The one thing is we provide the infrastructure, but everyone uses it in their own way. And it's good. This is the way it should be. We need to be agile enough, and our infrastructure needs to be agile enough that the user, big or small, will be able to use it in their own way. And the other thought is the chicken or the egg question. We are talking a lot about digital twins nowadays. And is a strategy really a part of the digital twin, or is digital twin as a concept part of the strategy? In the sense that, do we have a given spatial data infrastructure and extend it so that we get a digital twin, or is a digital twin the overall concept that we have to build up? So thank you.
Well, good morning. I think I'll be running through some of the same aspects as Christine just went through in terms of how the digital twin is coming to life across the globe, and particularly in terms of the UK itself. So I'm Nigel Clifford. I'm here with the Geospatial Commission. I was promised a whoop from the Geospatial Commission. Thank you. That's the Geospatial Commission. Let me see if I can work this. Yeah. So I'm here with the Geospatial Commission, but I've got a couple of other hats which are somewhat relevant. So I'm president of the Royal Geographical Society, so looking at the future is really important to us. But secondly, my day job is with private equity. And some of those private equity conversations I'm having are showing that the digital twins, while we're talking about them in this room, they're being talked about, they're being enacted in many other places. So I'll bring in a couple of examples as we go. So, So the Geospatial Commission, Christine was talking about alignment. That's very much part of what the Geospatial Commission is there for. So to create a geospatial strategy for the UK, but also to work with the government to ensure that geospatial thinking is part of policy formulation, part of delivery, but also working with what we call the Geo6, so the big geodata providers, Ordnance Survey, Land Registry, Geological Survey, Coal Authority, UK Hydrographic Office, and Valuation Office, to make sure that their strategies are coherent with a national strategy. And we'll maybe touch a bit about that in a second. And then the other thing that we get involved in is how do we make available data, both public and private, cost effectively for the rest of the UK, particularly the public sector. In terms of the commissioners, I won't go through this in detail, but bringing together what's called an expert committee to help advise government on how to take forward that geospatial strategy. So we've got people there who are versed in land use, versed in the property market, telecoms, regulation, statistics and data. So bringing them together with the executive team and the Geospatial Commission to really think hard about the next 5 years, 10 years, 15 years with regard to the geospatial infrastructure and data releases. But I'm here today to talk about digital twins. And I'd like to start off with, you said May the 4th. I'll start with a different science fiction writer, which is William Gibson. Now, it's alleged he said this. No one can actually find him writing it down, but I like it. It's the future's already here. It's just unevenly distributed. And certainly with my private equity hat on, I've been involved in talking to people who are standing up digital twins for the last 5 to 10 years. Now, typically in early adoption, you get entrepreneurs, you get visionaries. In this case, it's actually those who've got a lot to lose if they get the operation of a big capital project or a really expensive facility if they get it wrong. So they're looking for an edge. And if you're running an oil production platform, that's $1 million a day. If you're running a refinery, then if it goes down for an hour, that's $250,000. So there's a huge business case advantage to avoiding those pitfalls and to optimizing your operations. But we're beginning to see that now leak across from what were niche cases into more of what might be termed the mainstream. And we're seeing that as the cost of technology fall, compute power is made available, algorithms are made available. And we're now beginning to see more and more examples in both the public domain and private domain. So I think in Rotterdam, you've got a fantastic digital twin with regard to the Port Authority. Roland van der Heijden, I don't know whether you're in the audience, but you're famous as the guy in charge of Rotterdam's city digital twin. And his assertion is that the digital infrastructure for a city will be as important as the physical infrastructure, the roads and other elements around the city. So there's the beginning of that movement. We've heard how other authorities are beginning to get their arms around the digital twin concept. But in our view of government, we're not here to pick winners. We're not here to start to stand up our own digital twins for the nation. We're here, particularly in the Geospatial Commission, as enablers. And so if the prediction is that digital twins are going to proliferate, then the question is, as a public actor, how is it we can help that? How is it we can enable that? And I think it's actually coming down to more of the softer areas rather than the harder technology areas where we can make the biggest difference. And it's not particularly bold, but kind of 3 areas where I think this is particularly important is around data. And we've heard a little from the previous speakers around the importance of data. And I'll talk about how data, we use the acronym QFAIR, which I'm sure many people will be aware of. it's got to be quality data, it's got to be able to be found, accessible, interoperable, and reusable. So how do we enable that as a set of public data custodians? The second element is that this is going to be an amalgamation of data. It's not going to be one stream. We heard earlier that interoperability is going to be the key. So how do you create the keys? How do you create the ontologies, the etymologies to be able to share this data and the standards? And also, how do you do that within an environment of security and trust? Not just in terms of, it's my data, I want to know what's happening with it, but also critical national infrastructure. We're potentially opening up Pandora's box with the level of insight into how cities are working, ports are working, airports are working, or even individual organizations are working. So those are three areas where I think there's going to be either friction or the opportunity to make improvements. Then I'd like to spend a few minutes just talking about how the Geospatial Commission has been thinking about interventions to smooth the process of creation of digital twins, not predicting how these are going to end up, not predicting particular use cases, because that's really for the market and for other departments to decide, but how do we create the framework to enable this to happen in the easiest way possible? So I'll pick on examples for each of those predictions. And probably the one where we've spent the most time within the strategic pillars that we've been pursuing is around the whole concept of QFARE data. So looking at, first of all, the quality of data. So the Geospatial Commission did, with its partner bodies, an audit of data across the public domain, the geospatial domain, and found areas for improvement. So there were targeted, funded interventions for data improvement programs. Then in terms of findability, setting up gazetteers, which allow particular vertical applications to find the data for land use or property use as easily as possible. In terms of accessibility, we had the same conversation around open data, commercial data. How do you receive a rent for that data, having spent the money to obtain it? And we've found a great British compromise in terms of releasing more and more open data, but doing that in a way which is somewhat protected. So it's there for experimentation, it's there for proofs of concept, but then if you are making a business of it, then there should be a conversation about a commercial return for the public data which is being provided. So that is now available, and particularly having run Ordnance Survey, that was always a big debate, and I'm really pleased that we found an accommodation with Ordnance Survey to create the data hub, which now makes that available and accessible. In terms of interoperability, one of the things that was done a couple of years ago now was to make freely available the unique property reference number and the unique street reference number for the UK, with a mandate for public sector distributors of data to include these keys in that data. So there's now a way of identifying and precisely positioning different data sets on top of a street or a property. So that, again, is helping with the interoperability of the data. And then in terms of reuse, creating a whole new licensing framework, which allows public sector data to be taken, used by entrepreneurs or by other companies to create derived data sets in the safety and the knowledge that there are good licensing frameworks and safeguards around it. So on the data side, I think quite a lot of activity, including striking a 10-year deal with Ordnance Survey to enrich the data with a view to this being used in more and more use cases, such as the digital twin. On the ethical side, I mentioned that this is going to be an amalgamation of public, private, citizen, machine data. There is generally a conversation going on about my data. Where is my data being used? I'm carrying a mobile phone. Where's my data going to be located? Who's going to be exploiting it? So the Commission and also government have been really thoughtful about how do we understand the limits to ethical use or the tolerance of particularly the private citizen to using their data in these kind of applications. And particularly as this is often real-time data, it's extremely valuable when you've got a digital twin looking at disasters or looking at planning applications or mobility, hugely valuable. So we ran a very comprehensive engagement with the public, interviewed and engaged with 2,000 citizens, 60 expert bodies, and produced a report looking at, well, how do we start to think about those tolerance levels, and where do we begin to stray across into areas where individuals would find it unacceptable to see their data being distributed. So that's now been published, I think, for about a year. And so all of these reports are online if you'd like to go and have a look. And then the final point was around security and trust, not as individuals, but across organizations, because you're not going to have a single silo of information creating your digital twin to create the maximum effect. It's more likely to have lateral data flows from different domains. So the biggest example that we've just been through and is now in rollout is creating the National Underground Asset Register in the UK. So previous attempts had been frustrated by the concern of competitors, both actual, real, and potential, in terms of sharing their information on the pipes, the ducts, the fibers, which they had control of, sharing that data with other players in their particular part of the commercial area. So getting telecoms organizations, water organizations, electricity and power organizations to share that data had been extremely challenging. And in the UK, we need to get about 700 organizations to collaborate to create this. I don't know whether you call it digital twin, but it's certainly some foundational information which is going to flow into that. So the good news is that we ran 2 proofs of concept, one in London, one in the northeast of the UK, and we began to engender this feeling of actually this is for the greater good. And not only that, it's good for me because I can now dig with certainty, I can make my plans with certainty, I can estimate with more certainty. And we estimate in the business case that around 400 million euros a year is going to be saved through accidental strikes and repair. So an interesting example of a convening body like the Geospatial Commission, thinking through foundational data which just isn't or hadn't been available, and then using its influence to create a business case, create a plan, and then get the right people into the room to start to design the preconditions for sharing that data. And very much building on the really great work that had been done in the Netherlands and Belgium in solving that same kind of issue. So those are some of the ways that, those 3 predictions of, well, we need decent data, we need to be able to share it, and we need to be able to trust each other while we're sharing that, how we've been thinking about that within the UK. And just leave you with one example where, we've spoken about private sector and public sector digital twins. We're seeing this in the geological survey, where they're creating virtual realities and 3D models, walkthrough models of their geology of the UK. This is an example from the Hydrographic Office, where they've set up a digital twin for training purposes and modelling purposes. So it's a model of a harbour in the north of Scotland, where using the depth of data they have, they can now simulate traffic, weather, tidal conditions, different variables to really stress test the navigators and the use of this particular harbour. So an interesting example of something which kind of started in the very heavyweight industrial context, now flowing right the way through into the public sector and day in, day out use. But I'll come back and just leave you that one thought, that while there's a lot of conversation around the harder elements of digital twins in terms of the technologies that are enabling this in terms of sensors and compute power, actually I think it's quite a lot around the softer elements of this. So the behaviors and the safeguards, as well as the data, that's going to make the difference. Thank you very much.
Well, thank you for those 3 keynotes. It was really insightful. Well, let's just get this out of the way. Is the digital twin part of the national strategy, or is the national strategy part of the goal of a digital twin? I think all of you sort of leaned in one direction, but really quick, let's get a 10-second answer on that. I'll start with you, Paul.
Yeah, thank you. For me, a digital twin is part of a strategy. It's not a strategy itself. First, I have to say it is a buzzword, and it is it's a new buzzword, but it is a buzzword and not more.
Christine?
You would have to define digital twin first. And I do think it is a buzzword, I agree. And I think there are different definitions of this going around. One is like a digital copy of a physical object or process. Other is a 3D city model. Other is STI extended. And now I do think that it belongs definitely to the strategy. And it is especially useful for involving users. And that is a big bonus here.
Very good. Nigel?
I'll see if I get anything thrown at me by the Geospatial Commission. I think if you actually talk about digital twin as it's a map, so you raised the reference point of a map. Would you say is the map the strategy, or is the strategy part of the map? I think what we're doing is almost agnostic. So you've got to have different uses in mind, and beyond those uses, you've got use cases. But I think setting out, well, this is the end goal, this is the manifestation of what we're going to be doing, potentially blindfolds you to where others may take this. If you're purely focused on it's going to be a digital twin, and that's what we're going to focus all our energies on, then maybe there's other uses or use cases which are going to be poorly served. So I would say it's one output from having a comprehensive geospatial strategy for the nation.
Thanks. Yeah, go ahead.
Maybe another, but for me it is very important, as she said, that we have a kind of definition for digital twins. It's very important, yes. And on the other hand, I think we need a kind of standard what we are talking about, because we have so many different digital twins. We have it for the cities, we have it for a country, we have it for the European Commission, and blah, 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 blah. And so we tried to find a connection between all these approaches.
Yeah, excellent. So, one of the common definitions that I've seen is an ecosystem of digital twins. And to your point, Nigel, they're coming from different sources. Some of them are generated, Paul, as you showed, by government for particular purposes. We saw yesterday afternoon an interesting one, a digital twin about palms and 40 million separate trees that are being managed as part of a conceptual digital twin. And then, of course, the urban environment. So I guess one of the questions I would have before I open it up for the audience here is digital twins, I think by concept is fairly easy to understand. We all can visualize what a digital twin would look like and its many purposes. But in practice, it's hugely complex. How do we deal with the information assets? I mean, we talked about the framework. We talked about Q-FAIR data that's being produced by government, but all the real-time data and data that's in intellectual property lanes by owners and operators, landholders. How do you imagine we're going to manage that data? How does that work going forward as part of a national digital twin? What are some ideas about how we handle that?
Well, no, I think the federated concept is part of the answer. When we started with the underground asset register, it was right, are we going to create a massive data cube and we will store all of that data, and then people will send us changes to that data and we will check it in and check it out. And very quickly you realize this is just madness, because you're going to have different standards, you're going to have different levels of rhythm to data being checked in, and you've also got a massive uphill struggle to say, we are going to own your data. And that just doesn't feel right in a mixed economy. So I think the idea of how are we going to manage the data, I think it's going to be lots of us managing the data.
Anybody else wish to comment?
Yeah, I like the work, the abbreviation KISS, keep it simple. It is not possible to solve every problem with a digital twin. I work for the federal government, and I try to answer with our digital twins question of the federal governments. And then I can work mainly with governmental data. and mainly with data from the federal state, because you know in Germany you have the so-called Länders, which makes this thing in Germany much more complicated than in other countries. But if you work with the data from the federal government, it becomes much more easier to work with it.
I think we definitely have to go for a federated model, as Nigel said. But I do also think that we have made a lot of experience already in different aspects of data management with the spatial data infrastructure. We have learned about standards, we've learned about data harmonization, modeling. So definitely we do bring a lot of experience with us where we can work on. I do think that the new part is that it's much more data, and it's not only geographical data we're dealing with the digital twin. And therefore, I do think we have to go further in the direction of data science, so artificial intelligence, algorithms, big data algorithms, and we need to not focus only on ways of dealing with data in the geographical sense, but more in the data science sense. And I think that would bring us further.
Thank you. Questions from the audience? Yeah, go ahead, find a microphone.
Yeah, hi, I'm Kevin Dobbs from the National Geospatial Intelligence Agency in the U.S. Christine, I liked your reference to paper maps, love them. You know, one thing I haven't heard anybody talk about, and I think is absent from this discussion, is the discussion of scale. We talk about data as though we're talking about things that are appropriate for every scale, and I think that matters. Can you comment on scale, use of data, and that as part of the discussion?
So I guess I'll start at the smaller scale, which was looking at the digital twins being built for the oil industry. They were down to individual meters, i.e. pieces of equipment, and what are those pieces of equipment doing, and how do we optimize those under different circumstances? So you got that kind of very atomic level information. And then I guess you're up to different levels when you're thinking about mobility data, and you're talking about population level data, and then another level when you're talking about climatic data. So I think one of the panelists was talking about a pyramid, and it's more like a Russian doll in terms of the levels of scale which are brought to bear to a particular problem. So that particular piece of equipment may operate differently under different climatic conditions. Okay, well, how do I get hold of that data? So I don't know whether that helps the discussion or the conversation, but I think having one view of resolution or one view of data scale is not going to crack it in terms of getting the optimum answer out of it.
In terms of scale, I think it is important, especially that we get the data together from the different scales. So there's, again, the aspect of the data harmonization on different scales so that they can work together and that we get interesting results or answer our questions on the different scales. And here, it is also important that global issues, or especially environmental issues, but also traffic issues, don't stop at the national borders. So I represent here the National Mapping Agency of Switzerland, but Switzerland is a very small country, and we have a lot of border cross-country cooperations. I think this is something that also has to be intensified also on a global level.
Yeah, I agree with Christine, but I want to make another point. I think we will go in the near future to dynamic digital twin. For me, this is a very important issue, because in the moment we talk mainly about strategic issues. We have time to answer the question, but in the near future we don't have enough time, and this means we need more computer power, more money, more stuff. And this is, for me, the real challenge, because the politicians, they want their answer now for their critical questions in the moment.
And I also found it interesting that on the scale question, I would imagine the whole concept of framework is going to have to evolve quite a bit as we learn more about those use cases and the scale demands of the community. So that'll also be a consideration. I think we have time for maybe one more question. I think we had a gentleman over here. Yeah, go ahead.
Hi, I'm Shiva Ravada from Oracle. Christine, regarding your question about paper maps, I do know kids who ask, what is a paper map? But again, coming back to the digital twin, a lot of the discussion is centered around a kind of a static digital twin. So do you have experience with like a dynamic digital twin, in the sense that you have a lot of data coming in and a lot of simulations have to be run to like really simulate what happens in the real world? So in your experience, have you seen any practical examples of dynamic twins?
Again, not to kind of walk the same path, but certainly in industry, it is dynamic. Yes, it's helpful having a plan view and more of a almost a point cloud 3D model of your facility, but it's what's going on in that facility, minute by minute, second by second, which is the interesting piece. So in those instances, they are totally dynamic, and that's really the value of them, where not only do you see what's going on, but you can do some what-ifs on it in terms of, okay, if production needs to increase by 15% and the throughput's going to be bottlenecked, where is it going to be bottlenecked? So yeah, certainly in the private sector, there's a lot going on there. And I think to an extent, if you look at some of the traffic modeling that's going on within the navigation apps, you could say, well, that's beginning to look a little bit like a dynamic digital twin, particularly when you're looking at public infrastructure being overlaid on it.
Go ahead.
I can mention maybe one use case we had at Swiss Topo. There was, due to glacier melting, we are having more and more problems of landslides in Switzerland. And there was a big landslide basically covering a whole village. It was quite dramatic. And we helped out there on simulations of whether any more landslides could occur and where would they occur, and helping out with the local agencies there to support in the natural hazard area. This is definitely an area that is very important, but I do think we also have to intensify these collaborations on this level.
Well, I think we're just about out of time. I want to thank our panelists for their keynotes and answers to questions. And I think I would end it by saying we talked a little bit about trust, but I think that's going to be a huge component as we go forward to try to work the national strategy, the trust among all players in this idea of a national digital twin. Thank you very much.